Hey guys, I missed you guys today. Had to stay home, deal with some family issues, but here I am at school, 4:25 p.m., and we got some video notes to cover. So we looked at quadratic, and we're going to go ahead and go back at linear and absolute value functions again. So we're going to start off here with this function, f of x equals 3. Remember that f of x stands for y. And before I forget, Jose, this is a shout out to you, Jose Silva. I think you were the one that asked me to do a shout out for you, and if I'm wrong, then I'll hear it tomorrow, I'm sure. Anyway, so here we go. So let's see, we're going to choose some input values. I'm going to go ahead and choose some negative numbers and some positive numbers. Remember that 0 is neither negative nor positive. Okay, since we know that y is equal to 3, well, it's 3 all the way down. It can't be equal to anything else because it says y is equal to 3. So this is a special type of linear function. It's actually called a constant function, because the y value is constantly 3. It doesn't change. The opposite of variable is constant. Okay? So let's go ahead and graph it. -1, 3, 0, 3, 1, 3, and so on. So here we go. This is a constant function. Notice the slope. The slope is 0, no slope. Okay, domain. So we're going to do it in both notations. This will be the third time you've seen it now on a video, so hopefully you're getting the hang of it. So we're going to go ahead and do interval notation first. So we're going to go from left to right. So on the left we have an arrow, so we're going to have negative infinity to positive infinity on the right. And then since we're incorporating all real numbers, we're going to say this is set notation. X is an element of all real numbers. No constraints. All real numbers. Okay, range. Okay, using the interval notation, the only range value on this line is 3. It's 3 all the way across. Lowest point is 3, highest point is 3. So we're going to just put down 3. Interval notation. So here's a quick screenshot of the different types of numbers. Now for the range, our number is 3. So we're going to go ahead and use integers, because 3 falls in the integers category. Okay, so let's go back here to our paper, and we're going to go ahead and do y is an element, and integers is, we used a z for integers. So I do a little double slanted line and then a z. So y is an element of integers, okay, such that y equals 3. And this is set notation. You first tell me what type of number is the range or domain. Okay, and in this case it's an integer. And then you constrain it if you have to a certain set. Okay, in this case y equals 3. Alright, let's move on. Next one, number 2. This is the parent function for linear. Okay, so I think I'm going to leave that for you to do. Easy one. Remember, choose some negatives and positives, plug them in, graph it, domain and range. So I'm going to give that one to you. This is the parent function for absolute value. because it's the basic one. There's no shifting left or right or up or down, no stretch compression. It's just the basic parent function. You know, I hoped you guys worked hard in class, but in case you didn't and you took advantage of that time, I do expect you guys please to do these problems here. Tell me the transformations left and right, up and down, if there's a stretch or compression, if there's a reflection. So I will be checking 4 through 9 tomorrow. Number 10 is one that you should be able to do, graphing the y-intercept. Go ahead and graph the slope. Please do that one for tomorrow. And then let's go ahead and do number 11 together. So you see the bars, okay? So what we have here is we have the absolute value function. And let's go back a page real quick and let's look at the parent. We really need to know what the parent looks like. So picking some numbers, some negatives, some positives, 0 in the middle, plugging it in. The absolute value of -1 is 1. Absolute value of -2 is 2. Remember, it's the distance from 0. How far is the number from 0? So notice the absolute value of any number is positive of that same number. So graphing this, oh, that's funny, I got those switched around. Oh well. -2, 2, -1, 1, 0, 1, 1, 2, 2. So I just want you to kind of get an idea of what this parent function looks like. Did you guys miss me? I planned on getting a whole bunch of grading done during the day, but I had a lot of family problems, people in the hospital and car problems going on. I didn't get anything done, but it was good that I was home to take care of my family. So there's the parent function, okay? So keep that in mind. So remember the other day when we talked about left and right and up and down, and we talked about moving the vertex on the quadratic? Well, we're going to move the vertex. Well, it's really not a vertex, but remember I like to call it the special point. So we're going to move the special point around. So let's go back to this problem here. So just like the quadratic, when you see a number inside of the bars, it's just like that left and right inside of the parentheses for the quadratic. So this is saying that we're going to move it 5 units to the right. 5 units. And it's the opposite, right. And here we have 2 units up. So remember that special point on the parent right here? So just follow the directions. 5 to the right, 1, 2, 3, 4, 5. 2 units up, 1, 2. So that's going to be our new special point. Again, looking back at the parent, here's the parent special point, and we moved it 5 over and 2 up. Okay? Now, the A value. In this case, the A value is 1. So that means we're going to go over 1, remember, and then we're going to apply the A value at this point. Since it's positive, we're going to go up 1. Okay? And because the parent is symmetrical, just like the quadratic, we can also go over 1 the other direction and up 1. And that's going to help us draw the new graph. Nice straight line. Now remember, it's not a straight line with a quadratic. Okay, come on. Having problems here lining this up. So yeah, we got this new vehicle recently, 2012 Toyota. Just died on us today. My wife and daughter were alone. It's crazy. Car problems. Okay, What else? Well, here's linear. You're thinking, well, what's the special point for linear? That's a good question. What is a special point for linear? Well, we go back to the parent, okay, y equals x, okay, that special point is going to go right through 0, 0. If you remember, it goes through 0, 0. Running out of time. Okay, when you graph your point, it's going to look like that. Here's your special point right here. So you can use parameter changes to do this problem as well. We got 2 units to the right. We got 4 units up. So that special point, 2 to the right, 4 units up. Okay, and then we just draw in our line. You know, the slope is 1. So it's just going to be just like the parent. Up 1 over 1. You know? I can get this to. So anyway, notice it's going through 2 on the y-intercept. 4 plus -2 is 2. There's your y-intercept. Slope is 1. Over 1, up 1. Over 1, up 1. Okay? All right. So let's see, what else do we got here? I think you're going to be good with this. Let's see how well you do with the -2. Okay? You know, we always start with the special point on the parent. The special point on the parent for an absolute value function. Remember, absolute value, you've got to remember, makes the V graph. Makes the V graph. And so the V special point is right here. And this number here tells us to move 1 unit up. There's nothing in the parentheses, nothing except the X. So we do not move it left or right. We do not move it left or right, just 1 unit up. Okay, apply the A value. Okay, so remember, we just go over a unit, and then we apply the A value. Are you still awake? Are you still with me? Are you listening? You go over 1 unit, and then you apply the -2. Since it's negative, we go down 2 units. And it's symmetrical, so we do it on both sides. Now notice, we have a vertical stretch. We have a vertical stretch. If that A value is greater than 1, okay, now I didn't do a very good job on that, but here's your A value, right there, 2. Don't look at the negative. The negative just makes that, that graph reflect over the x-axis. Look at the number. If that number is greater than 1, we have a vertical stretch. Okay, running out of time. Let's see what else. Let's see what else we got here. Okay, it says, well, I think what we need to do on 20 is we need to write the equation of this line, and I'm going to do it the old-fashioned way. I'm not even going to use the parameter changes. I notice that right off the bat that my y-intercept is -2, and by the way, that's the way I do it. I always start with my y-intercept when I'm doing linear, okay, and I work to the left. So then I figure out, okay, there's another point, so my rise is 2, my run is 1. So my slope is going to be 2 over 1. And I'm going to go ahead and use function notation on this. Function notation. Now, I want you to do as much of this worksheet as possible, but the ones that I circle, I really want you to have done, or at least attempt for tomorrow. Okay? Well, I'm out of time. I hope you guys have a good evening, and I'll see you guys tomorrow. I should be here.